In this video, we want to do a question related to IVT or intermediate value theorem. Suppose f is continuous function. If you remember from IVT theorem, it's necessary that the function to be continuous. Otherwise, we cannot apply IVT for that function. So we have a function that is continuous on the interval -3 to 4. And the only solutions of equation f of x equal 9 are x equal -2 and 3. Now, if f of 1, the value of the function at point 1, equals 12, then explain why f of 2 should be greater than 9. To get better understanding of this question, maybe it's not a bad idea to graph something for this question. Consider this x-axis and y-axis. Let's say we suppose -3 is here and 4 is here. The given interval is -3 to 4. So we have a function that is continuous at -3 to 4. So the function has no hole, no jump, no asymptote from -3 to 4. And the only solutions of the equation f of x equals 9, let's suppose 9 is here. So we suppose 9 to be here. Then the function that we have to imagine for f is a function that has two solutions for f of x equals 9. And those solutions happen at -2. Let's say -2 is here. So it would be here. And 3. So 1, 2, 3. We can consider it here. So f of x passes through these 2 points. And at no other points, it passes through y equals 9. So the only solutions to equation f of x equals 9 are only -2 and 3. So we can imagine something like this. So we can, for example, start from here, going up, then going down, and let's say we stop here. Attention, whatever you graph, this is important. It should pass from this point and this point. Why? Because f of x equals 9. Here f of x is 9. Has only two solutions. And those solutions are -2 and +3. The other way that you can graph, for example, your function can be something like this. Maybe you want to graph something like this. Let me show you. This function also satisfies this condition. F of x equals 9 only at 3 and at -2 and no other points, as you can see. But look at this. We want to also have this condition. F of 1 equals 12. So this graph for f doesn't satisfy that condition, because if you look, f of 1 right now here is something like 5, 6. It's less than 9. So I have to change my graph. So the other graph that I showed you before works in this case. So we can suppose our graph to be something like this. Now for this graph, we can say, okay, f of 1 is 12. So this new graph for f satisfies that condition. F of 1 is something like 12. F of x equals 9 has only two solutions at -2 and 3. Now, we want to prove, not by the graph, but we are graphing to get an idea. We want to prove that y f of 2 should be greater than 9. As you can see in my graph here, f of 2 is obviously greater than 9. Why it can happen that f of 2 be less than 9? let's imagine what happens if we want to graph something that f of 2, here is 2, would be less than 9, somewhere, for example, here. What happens if we graph something like that? Let's see what happens if we want to graph a function that passes through these 2 points, and also somewhere here that f of 2 is less than 9, opposite of this. And also don't forget, f of 1 should be 12, so also it passes through this point. Let's see what happens if we want to graph a function like that. So imagine you want to draw a function, a continuous function, passes through here, 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 and here, these 4 points. Let me show you better the points like this. If you want to graph something like that, for example, maybe you start from here, then you think, okay, I have to pass through here, then you have to go down and then up, because you want to pass through this point, and your function you want to graph is continuous. Somewhere here between 1 and 2, your graph, as you can see, should pass through a point that f of x equals 9. As you can see here, f of x is 9 again. But we have supposed, this is what we have supposed about f, that f of x equals 9 is only happens at negative 2 and 3. But by this graph, f of x equals 9 happens at negative 2, positive 3, and this extra point. But we don't want such thing. So this graph doesn't work. Let's try to draw it maybe from down and then go up. Okay, let's try another graph for our function. Maybe you are thinking to another graph, to graph it in another way. Maybe you want to start from here, pass through here, go up. Then you have no choice. You have to go down to pass through this point and then go up. Again, you have the same situation as the previous graph. So you cannot graph something without violating this condition that f of x equals 9 has only 2 solutions at negative 2 and 3. So as you can see, because f of 1 is 12, f of 2 you want, if you suppose, we know, we want to prove that f of 2 is greater than, but if you suppose f of 2 is less than 9, based on IVT, somewhere between 1 and 2, your graph crosses f of x equals y equals 9. So now that we have the idea of the proof, let's start doing the question. We start with the opposite of this that we want to prove. Actually, the method of proof that we use is the contradiction method. So we say let f of 2 be less than 9. Then what happens? Attention, you have a continuous function. F is continuous. We know this from the question. F is continuous. And now attention, you have a function that at point 2 has value less than 9. So we know if we have a function that at 2 it has a value less than 9. And also we know that f of 1, this is from the question, equals 12. Now from intermediate value theorem, we can conclude that there is a number c between 1 and 2. There is a number c between 1 and 2 that f of c equals 9. Why you can have this conclusion? Remember, in IVT theorem, we say if a function like f has different values at point A and at point B, so these are different values. Let's say this is 2 and this is 10. Then every value between 2 and 10, then the function takes every value between 2 and 10. Now here, in our question, the value of the function at 2 is 9, is less than 9. Let's say it is 8 or 7. It's less than 9. We know this. And at 1, it is 12, which is greater than 9. So somewhere between point 1 and point 2, the function f takes the value 9, because 9 falls between 12 and less than 9. 9 is a number that is less than 12 and is greater than the value of f of 2. If we suppose f of 2 is less than 9, for example, if we suppose f of 2 is 7, 5, any number less than 9, by IVT we can conclude that there is a point C between 1 and 2 that f of c is 9. And now this conclusion that here we have, this conclusion contradicts what we had here. We have suppose f of x equals 9, look at here, happens only when x is negative 2 and 3. But here we have one extra point. We know somewhere between 1 and 2, let's say 1.5, 1.2. F is 9. And this contradicts what we have supposed about f. So what we can conclude? We can conclude that never happens that f of 2 is less than 9. So let me write down this here. But we know f of x equals 9 only happens for f at x equal negative 2 and x equal 3. So f of c equal 9 cannot, which shows that our supposition here, what we supposed here, is not right. It shows that f of 2 less than 9 is not true. Also attention that f of 2, attention also f of 2 equal 9 can't happen. Why? Again, because attention, f of x equals 9 happens only at negative 2 and 3. So at 2 the function cannot be equal to 9. F of 2 cannot be less than 9. Also f of 2 equal 9 can't happen. So what can be f of 2? So only f of 2 can be greater than 9. And this completes this question. I thought this is a nice question about intermediate value theorem, so I shared it with you in this video. I hope you liked this video. If you liked this video, please subscribe in my channel and see you in the next videos.